The out-of-state tuitions in dollars for random samples of both public and private four-year colleges in a New England state are listed. Find the 95% confidence interval for the difference in the means. So this wants us to find the confidence interval or the difference in means. So you're going to have a formula that has mu1 minus mu2 in the middle of your confidence interval. And you're going to have something over here, something over here. Now we need to figure out if this is the confidence interval using t of alpha over 2 or if you're using z of alpha over 2. And it looks like you're using t because they're giving you a sample. They're giving you two samples. And the only way to figure out the standard deviation from a sample is to plug it in your calculator, since they don't give you a population sample or a population standard deviation. So we have confidence interval 95%, confidence level is a 95%. And now let's find our x bar 1, our x bar 2, and so on for each of those. Let's plug those in our calculator. So you go to stats and edit. And as you can see, I've already put mine in here just to save a little bit of time. And then you hit stat, or first, we hit second quit to get out of that. Stat calc, first for our stats, and we want L1, calculate. So x bar 1 is 16,147.5, and our sample standard deviation is 4,023.7. And edit 6. So we have x bar 1 is 16,147.5, and 1 is 6. Our sample standard deviation is 4,023.7, and our degrees of freedom are n minus 1, which is 5. Now let's do x2, or mu2, I'm sorry. So again, I've already put those in my calculator. So I'm going to hit stat, first var, and now we're going to make this L2. So we hit second, L2, and calculate. So x bar is 9,039.9, and sample standard deviation is 3,323.5, and n is 7. So x bar 2 is 9,039.9, n2 is 7. Sample standard deviation is 3,325.5, and now our degrees of freedom, n minus 1, is 6. So if our confidence level is 95%, we have to compute our t of alpha over 2, and remember to do that, we need to use the lower degrees of freedom, which is 5. So our degrees of freedom is 5, which means our t of alpha over 2, let's find that. So we have degree of freedom of 5, and our confidence level is 95%. So our critical value, or our t of alpha over 2, is 2.571. We're just going to use 2.57. 2.57. Okay. And I've already written out the equation here, just because it's a little long. So let's plug in our values to this equation here. So we have x bar 1 is 16147.5 minus x bar 2 is 9,039.9 minus t of alpha over 2 is 2.57 times the square root of s1 squared is 4,023.7 squared over n1 is 6 plus 3325.5 squared over 7. And to save some time, I'm just going to write mu1 minus mu2, and then same thing minus or plus same thing. This is the spot where it changes here. Plus mu minus. So let's put that into our calculator here. So let's do this part, and then we're going to have this part separately. So let's do the first part of it. So we have 16147.5 minus 9093 or 39.9. So that's 7107.6. So the red part is 7107.6, and then we have minus, and then we have our orange part. So let's do 2.57 times the square root of 4023.7 squared divided by 6 plus 3325.5 squared divided by 7. And we get 5315.7. So 5315.7, and then we have our mu1 minus mu2, and again we have the same numbers, 7107.6 plus 5315.7. So let's plug those in our calculator now. So we have 7107.6 minus 5315.7. 1791.9. So we get 1791.9 less than mu1 minus mu2 is less than 7107.6 plus 5315.7 is 12,423.3.